Hello friends, in this tutorial, which is the complement for the first tutorial, we complete the design. We just have to provide the data for the nodes. The data which we need for the nodes is the elevation and base demand. If we look at the map, we can find the elevation, so we can bring the elevation from the map. The blue one is the elevation of the ground. I choose here, and you see the elevation is 685.838 meter. And also you can see the elevations, and I provide the note here, which is the elevation is 679.84, and here is, yes, you can just look at the map and bring the elevation. It takes time, so I provide the elevation for the nodes. The first one is 685.83. You can, yes, that's the elevation. Just click on the node elevation 0.838, and also we need base demand. We can calculate base demand in different way. Also we need this node, so we need the elevation for this node. You see, provide node here 679.844. Also you can provide it. In the same way for all the nodes, you can provide elevation. Now I provide the elevation for all the nodes. Okay, I provide for the elevation for the tank also. This elevation just belongs to the ground. Now we have to provide base demands for the nodes. Here you see it's a loop, so the calculation for the node is different. Water demand for the number for the houses, all houses, and we divide by the number of nodes for the loop. But for branch, in the different way. For branch, we calculate the number of this houses, the water for this house, and provide the demand for this node differently. And for this one, we calculate the number of houses here and for the school, and provide water to this node. That is the method which we provide the water demand for the nodes. Look, provides water for a house more than in one direction. For example, if we have this house, he can take water from here and also from here. Here we have 90 houses and we have 6 nodes. So for each home we need 0.059 liter per second for each home. And also we have 90 house, so the demand equal to 90 multiply 0.059. That is the demand. Divide 6 naught. Yes, it equal 0.88. You can use 0.89. I input 0.89. for the most simple way is just from select region. You can select the region of the nodes. That is the region. And it group it. Junction, it means node. And choose base demand. You can provide 0.89 here, the demand for each node. Okay. Now each of these six nodes, the demand is 0.89 for each node. Let's check. You see the base demand is 0.89. 0.89. But this dead end type, we have to calculate the houses on the node and provide the demand. Okay. The number of houses. We have 17 house. We can provide the demand for the last node. Okay. 17 house. Calculate the demand for the 17 house. 17 multiply. Okay, the demand for the last node is 1 or 1.1 is better. And for this one also the same, 1.1, because the number of houses is equal. This node has 10 house and the school. We have to calculate demand for the school and for the houses. For the school, we need 0.16. School. For school we need 0.16, and also we have 10 houses. 10 multiply 0.059 and plus 0.16 equal 0.752 for the node. For this node we have to provide 0.752 liter per second. Now we have to provide the pump curve and the dimension for the tank. We have to find the dimension for the tank. For finding the dimension of the tank, first we have to know the total volume of water which we need each day. So let us first find the total volume of water. Total volume of water equal to demand multiply population, that is the demand in liter, divide by 1000, it will be in meter cube. 1000, it will be in meter cube. So daily we need 262.8. So if we use 0.18 volume, so that volume of tank will be 47, but I prefer to use 0.30 of total volume. So I change the formula, just provide 0.3. Sorry, here I should have to change to 0.30. So 0.30 of total volume equal to 78.84. And if I use diameter 5 meters, so the area of the tank will be 19.63. And I choose H of tank 4. So now I find the volume of tank, which equal to 78, and diameter of tank 5, and height of tank 4. Let's provide it to the Epanet. You see, we have that is elevation. Elevation is the elevation of ground. Initial level, we have initial level, minimum level, and maximum level. I try to explain what are these levels. Okay, you see ground elevation. We can find ground elevation from the map, and maximum level is the highest point of the tank, which can store water. Initial level is a level between maximum and minimum level. Minimum level, it is the level of the pipe which take water from the tank for residential area. But inactive volume or base elevation, inactive volume is the volume below the minimum level. The volume stored below the minimum level, it's a good idea to clarify water from any small particles in the water. It's like filtration. Instead to go to the residential, they can sediment inactive volume. Okay, I provide minimum level is 20, and initial level let be 2 meter above minimum level, which is equal to 22, and maximum level is 24. As I told, 685 is the ground level of the tank, and diameter is 5. So you see, maximum level minus minimum level is 4. As previously we calculated the height of the tank, which is 4. Let's provide the data for the reservoir. Okay, reservoir could be lake or river or the well. If it be a river, you can directly or river or lake can directly provide the ground level. But if it's a well, you have to provide the elevation of water inside the well. So you see, the ground elevation in the reservoir is 687, and I assume that the depth of the well is 300. So 687 minus 300, it will be 387. So the surface of water inside a well is 387 from head, total head. From head pattern, you can provide the fluctuation in water inside the well. But provide just 387. I think suppose that 387 is the minimum water level inside the well. We have to find the pump curve, and the pump should provide water to which head. So the head, we can find the head from the ground elevation of the tank, which is 685.83, and also 24 meter. The tank is higher than the ground elevation, so you can sum 24 to this number and minus 387, which is the highest level of water in the well. 385 is the ground elevation of the tank, plus 24 plus 24, it equals 1709. And let's find the elevation of water in the well, 385. So 387 minus 387. So the pump should deliver water to this head. But the efficiency pump decrease over the years, so we provide more head. So let it be 330 meter. I choose 330 meter. And also which discharge I try to find is the maximum discharge. The peak flow is 867 liter per second. I choose 12. Choose 12. Okay. 330 meter maximum head and 12 liter per second discharge. Pump from browser. Choose curves. Add. Double click. Okay. Flow. 12. 325. 330, sorry. Okay. You see that is a pump curve. Directly generate a pump, the program, which is a head curve. Provide to the pump. The name of the curve is 1. Provide 1. Program recognize the number of head curve. Okay. Select all. Group edit. Pipes. Diameter of pipe. I choose at first trial 200 meter. Okay. Check. You see 200. Okay. Run. Run was unsuccessful. What's the problem? There is a node is unconnected. Let's find it. View. Find node 1. Yes, that's node 1, which it's non-connected. You can delete it. Yes. Node 2. You see node 2 also unconnected. We can delete it. Yes. This zoom. Okay, that's our location. This time let's run. Run was successful. Great. Links, map links. You can velocity, and notice you can choose pressure. Okay, you see the, and also legends appeared. You see the color option, fluoro, open. You can magnify the row size. Okay, you see the size flow, the direction flow, and also from report, mm, we hide the background. Okay, you see the pressure. Before in front of each house should be the pressure greater than 15 meter. The velocity should be 0.6, 0.9 for diameters less than 300, and also velocity 0.9 to 1.5 meter per second for diameter greater than 350. That is the limit is for the velocity. But sometimes you can't get this criteria because it not be applicable. So you have to ignore them sometimes. See 0.06. Now we can change for velocity, which is too much. We can decrease the pipe diameter. This one is good. 0.4, 0.6. Velocity is not much. You can select all, change the diameter, change one pipe. Let's change 150 because the velocity at first trial is so small, so you can increase by decreasing the diameter. Run again. Okay, you see the velocity change. This time also we don't have problem with the pressure because pressure is good. 0.59. One 1.03. I can change this one to 150 because the velocity is too much. Run again. 0.46. It's good. In this way you can change the velocity till you get the limits. This one 0.25. You can change it to 75 milli. 0.27. But we have to care about the head. This pipe is 0.13. Can change it to 50. 0.5 is good. But let's check pressure. This pipe, there's no problem, it's good. In this way, you can continue till you get the pressure greater than 15, and the velocity. Sometimes you can't control the velocity; it will be less than the limit is, because here we have so small discharge. After changing the diameter, head in every node is good, but sometimes we can't get the good velocity, especially for loops. You see this in 0.49 is good, 45 is good, 42 is good. 0.38 is also good. We have 0.3 also is good, but this two one is so small. Also from report you can find the results. You see it's the demand, head, this pressure, that's the pressure, that's the reservoir zero, or also you can find the data for the link, network links. You see that's the flow in each pipe, that's the velocity, that's the velocity. This two one is small, other is good, that's the head loss. And also from legend you can change the colors. That is all. I hope it's be helpful.